Everyone, Mr. Hissner here, and today we are going to look at parallelograms in sort of a new fashion. Instead of what we were doing last week, which was looking more at parallelograms like with algebra, numbers, and stuff involved, this week we are going to be doing the dreaded parallelogram proofs. And more importantly, I think we're just going to look at these for 2 days, 3 days. Then we're going to have a little bit of a project at the end of the week. So let's just jump into this. So things to consider. You know, parallelograms have several features, of which we just looked at four of them. We looked at 4 of them pretty in depth, right? However, I think the defining feature that we are going to use for this lesson, for today, we will use the fact that opposite sides are parallel. Hence the name, parallelogram. Okay, so which one did I give you guys on your thing? Hold up. Why? Okay, so I'm gonna do number 2. That's what I thought. So let's hop down here. Numero dos. One thing that I believe we need to keep in mind is we have seen typically like we're told that these 2 lines are parallel, and from that information we can conclude that, let's say, these 2 angles, for instance, are congruent. However, it is possible to be told that these 2 angles are congruent and then conclude that the lines then are parallel. And in fact, that's mostly what we see in this topic, is that oftentimes we use what's called the converse of the alternate angle theorem. So if the angles are congruent, then the lines are parallel. So let's just go through and look at this. So we have 2 things of given information. So 1, 2, wx congruent to yz, and wz congruent to yx. So that's this one, and this one, that's this one, and this one, and this is given. That's given. And so what do we have here? Let's just finish this off. So a lot of the times while we are doing this, we need to think of ourselves, what did we just prove the last time we proved stuff? And it was triangles. And if we look here, we have this. Hey, isn't that a third side there? Yeah, that's xz, and that is congruent to zx, and that is reflexive. So if I'm looking at this, remember this? Side, side, side? Yeah, I mean, here, pretty simply, we can do what I would consider to be like the most simple triangle proof. Is always side, side, side. So I'm just going off of things that we've done in the past. We're given 2 segments. We got a shared side. Now we got some side, side, side congruence. But what did we learn after this? Well, we said we could take it one step further. If the 2 triangles are congruent, then their corresponding parts are also congruent, CP/CTC. Now notice, remember what I just said up here, that if the angles are congruent, then the lines are parallel, right? And so what we want to prove is kind of what I highlighted up here, that opposite sides are parallel. So we need to use some sort of congruency. So what do we know? If these 2 things are parallel, then we know that these corresponding angles, the corresponding parts are congruent. Okay, because that's what CP/CTC says. It says every single part of the triangles are the same. Where'd this go? Why is this doing this to me? And so rather simply, we can just say, okay, WXZ is congruent to angle YZX, and also WZX is congruent to YXZ. So those angles in the corner that I highlighted here, they're congruent, and why? Well, because the triangles are congruent. That's what CPCTC is just saying. So all these parts are congruent. But what does that mean? Well, if, just like we saw up here, if the angles are congruent, then the lines are parallel. So if the angles are congruent, if these yellow angles are congruent, that means that we have this region here. Then it means that these lines are parallel. If the angles are congruent from the green ones, where'd that go? So we would have these ones. Oh no, I did these wrong. Oh, goofball. My bad. Green ones are here. Yellows are here. So if we have those ones, and then we will have these angles as well. So just doing those two pairs. Let me just, yeah, we'll leave it like that. Those two pairs. So we have, because those angles are congruent, then we know that the opposite segments are congruent, are parallel. And like I said in the beginning of this is the alternate interior angle converse. It's if Q then P. This is the converse. So the opposite sides are parallel. So that means that this quadrilateral, this is X, Y, Z, W, is a parallelogram. Why? Well, because that's literally the definition of a parallelogram. If the opposite sides are parallel, then it is a parallelogram. That's what a parallelogram is. So what do we do here? We did something that was very familiar, which is just using some very simple triangle proof, using CPCTC to say we have some alternating interior angles, and then that's the converse, makes those, because the angles are congruent, then the lines are parallel. That's what the converse of AIAT says, and thus it's a parallelogram because parallelograms have parallel sides. As you can see, this one will probably be very similar as well, this one as well. So, thanks for watching.